So here we have another two-step equation. Again, I'm going to begin with the abstract, even though when I'm working with the students, I personally would like to start with the concrete. So we have negative 15 is equal to 4x minus 7. Um, there are two numbers that I want to get rid of, this negative 7 and this 4. I'm going to begin by moving this 7. In order to move the minus 7, I'm going to use inverse operations, which means I subtract 7. Properties of equality say whatever we do to one side, we must do to the other. We know that negative 7 plus 7 is 0, so that part is gone. I'm left with 4x on the right side. And on the left side, I'm left with negative 8. Right, I have more negatives than positives. At this point, I have a 4 and an x next to each other. Since there's no sign in between them, we know that that's multiplication, and the inverse operation for multiplication would be division. Again, properties of equality say whatever we do to one side, we must do to the other. So 4 divided by 4 is 1. 1x would be x is equal to a negative divided by a positive is going to be a negative. 8 divided by 4 would be 2. So according to the work that we did, our answer is supposed to be x equals negative 2. I can check my work by replacing the x with the negative 2 in the original equation. Negative 15 is equal to 4 times negative 2 minus 7. Order of operations says we do multiplication first. Positive times a negative equals a negative. 4 times 2 is 8. Negative 8 minus 7 would definitely give us negative 15. So it looks like our answer is correct. Using the virtual manipulatives, I have a scale. It's currently balanced. According to the equation that we were given, on the left side, we have 15 negatives. These are in groups of 5, so there's my 15 negatives right there. On the right-hand side, I'm supposed to have 4 x's. 2, 3, 4. Organize them a little bit more. And I'm supposed to have 7 negatives. So there's 5 of them. And I need 2 more. 5, 6, 7. There we go. And since that's the equation that we were given, then let me tell the scale to balance. So that's what we were given. Here's the equation that we were given. I'm going to check first to see if I can take the same amount from both sides, right? In this case, on both sides of the equations, I have negative ones. So that means that I can take some negatives out of each side. So if I take 5 away from here, I would have to take 5 away. 5 away from here. No. Okay. 4, 5. It would still be balanced. I still have 2 extra ones here. I want to move them out of there. So that one and that one come out. That means I need to take 2 out of this side in order for it to continue to be balanced. Now that I have only the x's on one side and my constants on the other, I can now split them up into 4 equal groups. Right? Maybe I'll go something like that. 1 in each corner. So I'm going to take these and split them up into 1 in each corner. So 1 here, 1 there, to represent each one of the x's. 1 here, 1 here. So we have split up everything on the left side into 4 equal groups, everything on the right side into 4 equal groups. That must mean that one of these x's is equivalent to 2 negatives, right? So x must be equal to negative 2, just like we saw it on our equation. And we can test it to see, hey, if I take out an x and I take out 2 negatives, does this go back to being balanced? Perfect. Okay, let me take 2 of these out and 1 of these out. Yep, it's still balanced. take two of these out and one of these out. Yep, it is definitely balanced. So that means that x is equal to -2. Another way in which we can work this problem out is using manipulatives. Here we go. So I drew here my 4 boxes, and you guys know that I like to use boxes to represent the variables, and it means that I have this box, and each one of these boxes has the same amount of items inside. So on the left side, I have -15 counters. That means that on this side, including what's inside these boxes, I should have a total of -15 counters. Right now I have -7 counters over here. So that means that I could, just like in my equation, take these out to show what's left over that would have to go inside the boxes, right? If 7 of them are outside the boxes, we can say, these are the 7 that were outside the boxes. This must be what's left for the inside of the boxes. Well, I have 1, 2, 3, 4, 5, 6, 7, 8. That means I would have to split these 8 counters in between all of my boxes, right? So 2, 4, 6, 8. 2, 4, 6, 8. I have the same amount on both sides. If I put these back over here, I'm supposed to have a total of -15 counters altogether when I go over here to double check. Right, there's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I do have a total of 15 negative counters. And my answer is x is equal to whatever ends up being inside one of the boxes. Well, one of the boxes has 2 negative counters. That would be my answer.